Welcome to software testing. After watching this video, you will be able to define the terms functional testing, non-functional testing, and regression testing, and compare and contrast typical testing levels. Software testing is the practice of integrating quality checks throughout the software development cycle. The purpose of testing is to check whether the software matches expected requirements and ensure error-free software. In order to test software, the team writes test cases. These test cases are written to verify the functionality of a software application and ensure requirements have been satisfied. Test cases can be written in different stages of the SDLC and may vary depending on the type of test or the method used to develop the software, such as Agile or Waterfall. A test case contains steps, inputs, data, and the expected corresponding outputs. Regardless of the test type or development method, test cases should always be written after requirements are finalized. Software testing helps evaluate the software to identify whether or not the software product meets requirements and is error-free. Types of testing can be broadly classified into three categories: functional testing, non-functional testing, and regression testing. Functional testing usually involves black box testing, which is a method of testing without looking at source code or internal structure. Functional testing is only concerned with inputs and corresponding outputs of the system under test, also called the SUT. It is entirely based on testing functional requirements, and functional testing can be carried out manually or using automated tools. The goal is to test the functionality of the application, making sure the application is usable and accessible. Functional testing tests the SUT to make sure it meets functional requirements. Functional testing makes sure that when user errors or input edge cases do occur, the software handles those exceptions seamlessly by displaying appropriate error messages. Non-functional testing includes testing the application for attributes like performance, security, scalability, and availability. Non-functional testing checks to see if the SUT's non-functional behavior is performing properly. Non-functional testing should answer questions like the following: how does the application behave under stress? What happens when many users log in at the same time? Are the instructions in documents and user manuals consistent with the application's behavior? Does the application behave similarly under different operating systems? How does the application handle disaster recovery? And how secure is the application? Regression testing, also called maintenance testing, confirms that a recent change to the application, such as a bug fix, does not adversely affect already existing functionality. Regression testing should occur when there has been a change in requirements or when defects have been fixed. In order to conduct regression testing, all or some of the test cases should be selected to test against the application. Regression test case selection and prioritization can be challenging and can depend on several factors. Common reasons for regression test case selection include cases that have frequent defects, contain frequently used functionality, contain features with recent changes, or are complex test cases, edge cases, and randomly successful or failed test cases. Now that we have discussed different types of testing, let's discuss testing levels. There are 4 testing levels: unit, integration, system, and acceptance. Each level occurs at a different time in the SDLC. There are 4 different levels in order to reduce the amount of time spent on testing by preventing overlap. We will discuss each of these testing levels next. Unit testing refers to the tests that verify the functionality of a specific section of code, usually at the function level. It is performed by the software developer or engineer during the development phase of the software development lifecycle. Unit testing aims to eliminate construction errors before code is integrated with other modules. Unit testing is intended to increase the quality of the resulting software, as well as the efficiency of the overall development process. Integration testing seeks to identify errors when two or more smaller independent code modules are combined. Integration testing is another type of black box testing. Prior to integration testing, smaller independent code modules that passed unit testing are incorporated into the larger software application. After modules are integrated together, then integration testing can occur. Integration testing exposes bugs that occur when those smaller units of code interact with each other. Integration testing uncovers deficiencies in communication with a new module in conjunction with other existing modules, databases, or external hardware. Integration testing uncovers situations where bugs develop due to differing programming logic between modules, for instance. Also, sometimes during module development, requirements change, and the module isn't fully unit tested. Poor exception handling can cause problems when modules are integrated together. System testing occurs after integration testing and is conducted on a complete integrated system to evaluate the system's compliance with its specified requirements. It validates the system as a fully completed software product. System testing is both functional and non-functional. And system testing is done in a staging environment, which should be similar to the production environment. And finally, acceptance testing is formal testing with respect to user needs, requirements, and business processes. It determines whether a system satisfies the needs of the users, customers, and other stakeholders. Acceptance testing is usually done by the customer or the stakeholders during the maintenance stage of the SDLC. In this video, you learned that there are 3 categories of testing: functional, non-functional, and regression. Unit testing verifies small independent chunks of code. Integration testing looks for errors when 2 or more small chunks of code are combined. System testing validates the system as a fully completed software product. And acceptance testing verifies correct implementation of user requirements and business processes.